Hey guys, since Facebook is hiring again, so we can start solving Leetcode questions for Facebook to prepare for the Facebook interviews. And here I have already got the most popular Leetcode questions for Facebook for the past year. And we can start from solving the first one. So let's get it. All right. So for this question, we are going to print out the nodes of a binary tree in the vertical order. So here's a question. We're going to be given the root of a binary tree. So here, pay attention of a binary tree. So a binary tree will have maximum two nodes, two child nodes, the left one and the right one. And then we're going to return the vertical order traversal of the node's value. And the order will be from top to bottom. And then if we have the two nodes in the same row or column, we're going to have it in from left to right. So let's look at this example. So we have a root node of 3, and then on the left is 9, and the 20 on the right, and the 15 and the 7. So the output for this one would be 9, 3, 15, because 3 will be the top, and the 15 will be the bottom. So like this is the first requirement. We're going to print it from top to bottom for the same column ones, and then 20, and then 7. So the output will be 9, 3, 15, 20, and 7. And the second example with this input, so we're going to print out 4 first, and then 9. And then we have 3 in the same column, 3 nodes in the same column. So we're going to from top to bottom and the left to right. So top, left, and the right. So 3, 0, 1 for this row, for this item, for this column. And then we have 8 and 7. So how are we going to solve this? This seems to be pretty tricky in the very beginning, but this is a tree, right? So usually for trees, we usually like try to traverse through the tree to get all the nodes, to travel through all the nodes. And while we do that, while we travel through the trees, we can assign a value to each node. So what we can do is like, for example, when we travel through the root node, we can assign the value of 0. Let's say this is column 0. And then we move to the left, we can assign the node with the value -1. That's, which means this column for this node will be -1. And when we go right, we can assign a value to this node as a 1, so that we can know this node is on column 1. And then we travel again for this node, it will be 0. 1 minus 1 will be 0. So this 15 will be on column 0. And the same for node 7, we can assign the value with 2 because it's on the right of the column 1. So it will be 1 plus 1, which is 2. So we can travel through the tree and assign every node a value which indicates the column of the node. Now we have to, so we can, now we have the columns, right? How can we save the nodes in the same column from top to bottom and the left to right? So we have two ways of travel through a tree, BFS or DFS. So in this question, I'm gonna do BFS. The reason is for BFS, we're gonna travel through level by level. Like I'm gonna travel through the first level first, the nodes on the first level, and then the nodes on the second level, and then the nodes on the third level, right? So this one help me to maintain the order of top to bottom. So if I say like this 3 is on column 0, then I can push this value 3 to column 0. And then when in the next levels, if I have column 0 again, the new nodes will always be after this node 3. And also like to maintain the order of left to right, we can always travel the left node first, then travel through the right node. So we can maintain the order of left to right. Okay, so this is the main algorithm. So we can do BFS, travel from top to bottom, and then to the left node, and then the right node. And then while we travel through the nodes, we assign the value of the columns, the column value of each node. So let's try to start writing the code for this. So firstly, I can sorry, spacing issues. So firstly, we can maintain like a response, right? That's a return value, and that's what we're gonna return. All right. So this will be the return value we're gonna return from the hashing, and then we can maintain the queue equals we can import connections. So for BFS, we always use DQ so that we can have time complexity of order of 1 to pop from the left. And for every node, we're going to have a value, right? So the node will have the value. And also we're going to add another value for the node, which is the column value. Like for the initial root node, we can assign it to value 0. So let's say like, let's define the state for, so for every, so for every item, for every item in the queue will be node plus column. So for the first item in the queue, let's say it will be the root node itself plus the column value of 0. All right, and then we can also maintain like a column map where we store, we can import default dict, where we can maintain like all the nodes, in the for this column. All right, so now we just do the classic BFS traversal. While queue exists, what we can do is like we can have the node and the column popped up from the queue. All right, so and then we can append the node into the column map. So for this column, we're gonna append the node. So doing BFS, we can maintain the order from top to bottom. Now we need to maintain the order from left to right. So we need to traverse the left node first, left child node, and then traverse the right child node. So let's say if node dot left, if it has a left node, left column is equal to, so this will be the new column value. This is a new column value, and then we just appended this to the queue. That's the new column value. Then we do the same for the right node. Right node dot right, and the right column. The right column will be column plus 1. All right, so after we finish traverse through this is will be the BFS, where we traverse traveling through the tree. So once we finish travel through the tree, we can have a column map, which contains a dictionary of key as a column value and the value as a list of the nodes we have for the column. So now we're gonna return the columns from the minimum column to the maximum column. So what we can do is like we can simply do get all the keys. So we can just say all the columns are equals to column map dot keys, and then the min column equals to min columns. And then we have a max column, which is equal to the max columns. Now we travel from the min to the max. For column in range min to the max, and make sure we do the max plus one because this is exclusive on the left on the right hand side. So, and actually, let's do this in case like there's an empty list. Although I don't think it will exist. Now let's try to see how it goes. Oops. Let's see. Oh, this is for empty root. Sorry. So that's the edge case. Let's see how it goes now. All right. So I think it's pretty good. So time complexity for this algorithm would be, I think we just traverse through all the nodes. So it will be order of n. And while we are doing the trying to get them like all the columns and the appended values, it will be still order of n time complexity. And for space complexity, we just storing everything in a dictionary. And then we have a queue, which maximum we're gonna have all the nodes like in the queue, so which will be order of n as well. All right, so this is the end of the video, and I hope you will like it. And I'll post the questions in Medium, and I'll see you guys tomorrow.